It began as a silent nightmare at Tower 22 inches Jordan. A swarm of Iranian-designed Shahed 136 drones flying low and slow to evade legacy radar slipped through the defensive net, killing 3 American soldiers. For months, these $20,000 loitering munitions have terrorized the Red Sea, forcing the Pentagon to fire $2 million interceptors just to swat down cheap threats. In January alone, over 350 one-way attack drones were launched at Western assets, overwhelming kinetic defenses through sheer volume. But then the script flipped. Instead of exploding, a swarm of incoming suicide drones suddenly froze. They didn't crash or detonate. They simply banked left and landed gently at a designated capture zone like obedient pets. They hadn't been shot down, they had been stolen mid-air. And the genius engineering hack used to do it is rewriting the rules of modern warfare. The fundamental problem facing US forces in the Red Sea and across the Middle East isn't technological inferiority, it is a catastrophic inversion of the cost curve. When a destroyer like the USS Carney engages a swarm of Houthi-launched Shahed 136s, it is often forced to utilize standard missile, 2 SM-2 interceptors, which cost approximately $2.1 million per unit. Contrast this with the Iranian-designed drone, which, despite its lethality, is assembled from commercial off-the-shelf components for roughly $20,000 to $50,000. This is a financial asymmetry of 100-to-1, a ratio that is strategically unsustainable over a prolonged conflict. From the Bab el-Mandeb Strait to the jagged borders of Jordan and Syria, the sheer volume of threats is depleting magazines faster than the US Defense Industrial Base can replenish them. According to assessments by the Institute for the Study of War (ISW), this utilization of low-cost loitering munitions by Iranian proxies is a deliberate strategy of attrition designed not necessarily to hit targets, but to exhaust Western air defense stockpiles. The Shahed 136 flies low, hugging the terrain to avoid detection by long-range radar, and its composite structure gives it a small radar cross-section. Kinetic interception, physically hitting a bullet with a bullet, is proving to be a strategic trap. The enemy doesn't need to sink a ship to win, they just need to bankrupt the defense. This deadlock has forced Pentagon engineers to look beyond high explosives and towards the electromagnetic spectrum, searching for a flaw in the drone's brain rather than its body. Enter the solution which fundamentally shifts the paradigm from kinetic destruction to electronic hijack. The breakthrough didn't come from a larger warhead, but from a nuanced understanding of the Shahed 136's navigation protocol. While Iranian engineers have upgraded recent iterations of the drone with anti-jamming CRPA-controlled reception pattern antennas to filter out noise, they remain heavily reliant on commercial GNSS, global navigation satellite systems, for terminal guidance. The genius fix developed by US electronic warfare specialists involves a technique known as smart spoofing, or protocol manipulation. Unlike traditional jamming, which blasts high-power noise on the L1 and L2 frequencies to blind the drone, often causing it to switch to its backup inertial measurement unit (IMU) and fly a straight line into a random building, spoofing is far more insidious. It doesn't scream, it whispers a lie. The system works by detecting the specific handshake signal of the drone's satellite receiver and instantaneously broadcasting a counterfeit GPS signal that is slightly stronger and perfectly synchronized with the real constellation. By subtly manipulating the timing data within this signal, the electronic warfare unit can convince the drone's flight computer that it is drifting off course. To correct this perceived error, the drone's autopilot adjusts its flight path, unwittingly steering itself away from the target and towards a designated recovery zone. This is a zero-day exploit of the drone's logic loop. The Shahed believes it is flying straight and true towards its target coordinates, while in reality, it is being flown by remote control into a capture net or a barren patch of desert. It effectively turns the drone's own guidance system against it, neutralizing the threat without firing a single shot, and crucially without triggering the drone's loss of signal, self-destruct, or loitering protocols. This capability transforms the airspace from a shooting gallery into a digital trap, where the enemy's weapon is not just defeated, but acquired. Let's shift our perspective to the other side of the Bab el-Mandeb Strait, inside a mobile Houthi launch vehicle hidden deep within the rugged terrain of Yemen. The launch crew has just fired a salvo of 5 Shahed 136s, aiming them at a commercial vessel transiting the Red Sea. The distinctive lawnmower-like buzz of the MD-550 engines fades into the night as the drones begin their autonomous flight path. For the operators, this is usually a fire-and-forget mission. They pack up and move before a US airstrike can triangulate their position, waiting for the confirmation of impact on Telegram channels or international news. But on this night, something unprecedented happens. As the drones approach the terminal phase, the telemetry fed back to the ground station, or the lack thereof, tells a confusing story. Instead of the abrupt cessation of data that indicates a successful impact or a kinetic interception by a missile, the data stream begins to behave erratically. The operators watch in confusion as the GPS coordinates on their screens drift inexplicably. The drone isn't spiraling out of control or tumbling from the sky. It is banking smoothly, executing a controlled turn away from the target. To the Houthi commander, it looks like a guidance failure or a manufacturing defect in the commercially sourced flight controller. They frantically try to send a return to home or self-destruct command, but the link is dead. The drone is no longer listening to them. It has been seduced by a stronger signal. It's an eerie silence. The weapon hasn't been destroyed, it has simply defected. The crew is left staring at a screen that shows their lethal payload landing softly in a remote sector, controlled by the very enemy they intended to kill. Imagine for a moment that you are the flight computer inside one of these Shahed 136 drones. You are effectively a flying lawnmower with a warhead powered by a loud, vibrating MD 550 engine that pushes you through the night sky at a sluggish 185 kilometers per hour. Your brain is simple, built from commercial-grade electronics that you could buy on Alibaba. You don't see the world through cameras, you see it through a stream of ones and zeros beaming down from satellites 200,000 kilometers above. Your entire reality is defined by the Course Acquisition C, a code from the Global Positioning System. You know exactly where you are, and you know exactly where you are going, a set of coordinates programmed into your memory before launch. As you approach the target zone, perhaps a US destroyer in the Red Sea or a base in Jordan, your internal logic is singular. Maintain altitude, correct for wind, drift, and dive when the coordinates match. But then the world shifts. You don't hear an explosion or feel the impact of shrapnel. Instead, the invisible voice of the satellite suddenly gets louder. A new signal washes over your antenna, and it looks, feels, and tastes exactly like the GPS signal you have been following for the last 4 hours. The only difference is that this signal is slightly stronger, with a better signal-to-noise ratio. Your programming is designed to trust the strongest, clearest data source, so you lock onto this new stream without hesitation. You don't know it, but you have just been seduced. This new signal, the spoofer, starts telling you a subtle lie. It tells your navigation filter that you have drifted 2 kilometers to the east. Your autopilot, a slave to its code, immediately banks the aircraft to the west to correct an error that never existed. From the ground, it looks like magic. The drone stops its lethal descent and enters a holding pattern or a gentle glide. Inside the computer, the digital hallucination intensifies. The spoofing signal now manipulates your altitude data. It tells you that you are climbing, so you nose down. It tells you that you are over the target, so you initiate the terminal sequence. But instead of slamming into a ship's hull, you are guided into a soft capture trajectory. The spoofer feeds you a false reality where the ground is still hundreds of meters away, tricking you into stalling the engine or deploying a recovery parachute if equipped right over a designated sandy patch of desert controlled by USS Marines. You hit the ground intact, your warhead unexploded, your secrets exposed. You have been brainwashed by a beam of energy capturing the attacker without a single kinetic interception. There can only be one winner in this electronic duel, and it won't be the machine. The strategic implications of this capture capability extend far beyond the immediate tactical victory of saving a single base or ship. By successfully implementing this soft kill chain, US forces are effectively flipping the economic logic of asymmetric warfare on its head. For the first time in this conflict, the cost of defense has dropped below the cost of offense. We are no longer trading multi-million-dollar SM-2 or ESSM missiles for cheap fiberglass drones. We are trading electrons, which cost pennies for advanced loitering munitions. This restores the sustainability of US naval presence in the Red Sea and allows the Pentagon to preserve its precious stockpile of kinetic interceptors for high-end threats like anti-ship ballistic missiles, rather than wasting them on flying lawnmowers. It transforms a strategy of exhaustion intended to bleed the US Navy dry into a futile exercise for the aggressor. But the true value of these captured drones lies not in the money saved, but in the intelligence gained. A destroyed drone is just a pile of burning debris sinking to the bottom of the ocean, offering little forensic value. A captured drone, however, is an intelligence goldmine. Once recovered by US Navy EOD technicians or special forces, these intact Shahed 136s are shipped to laboratories for detailed dissection. Inside, engineers uncover the secrets of Iran's sanctions evasion network. They find the FPGA chips, the voltage regulators, and the inertial measurement units sourced from Western and Asian manufacturers. Reports from Conflict Armament Research (CAR) have already indicated that up to 82% of components in these drones originate from US companies acquired through illicit third-party networks. By capturing the hardware intact, the US government can trace the serial numbers on these microchips back to the specific distributors, closing the loopholes and tightening the chokehold on Tehran's supply chain. This capability is now being scaled up from experimental prototypes to theater-wide deployment. We are seeing the integration of these advanced electronic warfare suites, potentially including high-power microwave systems like Epirus's Leonidas, or upgraded variants of the SLQ-3 across the entire fleet, and at vulnerable forward operating bases in Iraq and Syria. The objective is to create a digital no-fly zone where Iranian proxies simply cannot operate. It is a form of area denial that doesn't require a single kinetic launch. If an adversary knows that their weapons will not only fail to detonate, but will be commandeered and used to expose their own supply lines, the psychological impact is devastating. It forces a fundamental rethink of their operational doctrine. The US is essentially building an invisible wall in the sky, one that turns the swarm from a lethal threat into a logistical delivery service for American intelligence agencies. The era of trading million-dollar interceptors for cheap moped engines is officially over. By shifting from kinetic destruction to electronic hijacking, US engineers have not only solved the catastrophic cost asymmetry problem, but have turned Iran's greatest asset into its biggest liability. This isn't just a tactical win for the Pentagon. It is the dawn of cyberkinetic warfare, where code is proving to be more lethal than high explosives. Iran isn't just losing their strike capability with every captured drone. They are handing over the blueprints to their own destruction, allowing Western intelligence to systematically dismantle their supply chains from the inside out. If you want to see exactly what US engineers found inside a captured Shahed 136 and the Western tech powering it, make sure to hit that subscribe button and check out our deep dive video right here on the screen. We'll see you in the next one.